Isotope is the same element on the periodic table of elements compared to the atomic form, i.e. the same atomic number or the same number of protons in the nucleus, but has a different number of neutrons in the nucleus compared to that form. Let's look at an isotope, and we're going to specifically focus on in the periodic table of elements, we're going to focus on this one, hydrogen, number 1 on the periodic table. Number 1 on the periodic table, it has a single proton in the nucleus, which has a positive electric charge, and then surrounding it somewhere around the nucleus is some kind of electron, which has a net negative charge. So you add up the 1 electrical negative charge and the 1 positive proton charge, and you get a net neutral 0 charge for the atoms on the periodic table. So let's go look at isotopes. Isotopes are versions that have different numbers of neutrons in the nucleus. So let's go look at an atom versus an isotope. So this is your atom. On the left, we have our 1 proton in the center of the nucleus, and it's surrounded in the electron shell by an electron. These two are going to be your isotope examples, common isotopes of hydrogen. And these will have different numbers of neutrons in the nucleus, as you can see by the addition of the red round particles labeled N, which are neutrons. So in the atom, we have a single proton in the nucleus of positive charge, and in an electron, we have a single electron of a negative charge, leaving the net to be 0 charge of an atom. If we look at these isotopes, they also have net 0 charge. You got your same single proton in the nucleus with the same single electron in the electron shell, leaving the net charge of 0 in both cases. Now the clue with the isotopes is that you have a different number of neutrons in the nucleus. In the atomic version, no neutrons. In deuterium, you have 2 neutrons. It's got a mass number 2 because you've got 2 objects in the nucleus. Tritium is when you have 3 objects in the nucleus, 2 neutrons and 1 proton, so the mass number is 3, summing 3 objects in the nucleus. These two, which have different numbers of neutrons in the nucleus compared to the atomic state, are called isotopes.